Hi there. I hope you're doing well. My name is Ramtin Abulfazli with the student ID 1014192226. I'm gonna go through the second assignment, both parts, which is settled in one file, however using two different CSV files. So first of all, on the top of the page, same as always, I'm importing the required modules and libraries, and then I'm defining a variable called file path to give it the routing of my this like tennis CSV file, tennis table kinda, and then I'm importing it using pandas. pd.read_csv will import the CSV file using the file path for that CSV file, and then I'm just running it to show you it has been successfully imported. I'm using this label encoder, and the reason why I have to use that is because the weather condition column, instead of being numerical, it's a string. So therefore, my model cannot figure out what this string is. However, by using this label encoder fit transfer, it will kinda convert it to float. Therefore, since our model doesn't care whether it's a string or a number, it's just following some patterns, it will behave the same as it would like understood a string values as well, kind of thing. So we're using a string in the column to be human readable, and then we convert it to float numbers to be AI or like computer kind of like readable. And then in the X values, I'm just dropping the last column, which is the label. Axis 1 shows that, specifies that this is a column and not a row. I put a comment features over here because basically we're dropping the last column label off. However, it will take all the other columns as its features. And then y, that after we drop that off, we are like taking the last column as the label. X train, X test, Y train, Y test, train test split. First is the features, second is the label. Test size, which shows that use 80% of the data as a training set and 20% only as a testing set. Random states just specifies that what random structure used for going through all this assignment and get it done. So it doesn't give us random numbers every time out of the blue. Over here, declaring the decision tree classifier, that what model we're going to use to split the data, basically. I mean, like to predict the data, I would say. Training the model that we specify, like this model decision tree classifier is defined into this variable. This can have the name of anything. CLF is like for classifier. Then we are training this using fit method, X train, Y train, and then we are also putting a variable named ypred, clf.predict. It's basically predicting the X test. So it is basically over here, like for example, 20% of the data over here is not shown to our model for training. So our model has not seen any of these values yet. We are like giving it only these only the feature values from 26 to 8, for example, in this line, and not the answer. In line 31, this is what I'm talking about. So X test, it will give these features, and then it predicts what would be the label answer, like is it yes or no. Accuracy score is comparing the Y test and ypred. So Y test is what the reality is, and ypred is what our model has predicted. And as you can see, the accuracy score is 1, which means like the model is pretty, like the values were pretty straightforward, and everything has been guessed correctly. However, since I tried it, if I change this to 3, Let's go through here. Let's go through this again. If I change this to 3, so it only gives 70% to training set and 30% to testing set, it will show me the 78% accuracy. And then the second part, it's the same thing, file path for COVID-19, the same way, dropping the label and declaring the decision tree. Testing size is 0.3 since it was as instructed. And then the accuracy score is 1 over here as well, which shows like the table was pretty straightforward. So thank you very much. Have a great day.